Hi guys. This video is about how to build a 5-axis CNC machine capable of metalworking. This video is a compilation of 6 videos showing how to build a 5-axis CNC machine that we have previously made, a total of 110 minutes of video. It's not easy to watch all 110 minutes of videos, you know. This video will help you understand how this machine is produced. If you watch this video and want to see more, please watch each video. There is links in the overview section. Assembly started. Start with this base plate. Install the linear guide, ball screw, and frame. After adjusting the linear guide, attach the joint block. Next is the ball screw. Right now, the screws are still loose. First, move the saddle to the ball screw housing side. Then, temporarily fix the housing in the ball screw nut. Move the saddle to the opposite side of the ball screw housing. When fixing the bracket, make sure that the ball screw is not stressed. Make sure there is no abnormal stress in the entire range of movement. There seems to be no abnormal stress, so tighten all the screws properly. If there is abnormal stress, go back to the previous process and redo the adjustment. Forcibly tightening under abnormal stress will break the linear block and ball screw in the worst case. The assembly is complete. I will start a final accuracy inspection. The height of the linear block is adjusted to 0.01 or less for all strokes. For the time being, there is no problem if the accuracy is this level. In the previous video, I explained the problem that the center of the y-axis stroke of this machine is a lot of offset from the center of the z-axis. This problem makes it difficult to machining. There are 2 causes. One is this angle frame interferes with the spindle. The other is that the linear guide block has reached the end of the linear guide. This structure needs to be improved. Let's see it with a 3D model for easy understanding. I will show you how to change this structure so that the y-axis can be moved more in the minus direction. Remove this part. Remove this column unit and install it in the opposite direction. Lower the linear guide by 10 millimeters. Install the brackets to reinforce the columns. After this modification, the y-axis stroke will move in the 15 mm minus direction than before. The ball bearings of liner git are usually sitting in an R or V-shaped groove instead of using a plain contact, from which some manufacturers are claiming 13 times as much load capacity. Linear guides are also extremely accurate. Errors are usually measured in the micrometers range. The addition of a preload into the guide can also increase accuracy and repeatability. Instead of having a small clearance between the track and the ball bearings, an interference fit is used. Advantages of ball screws. Highly efficient, requiring less torque, therefore smaller motor. Higher accuracy grades for greater positional accuracy. Lower friction, able to run at cooler temperatures. Available in rolled and ground types. Can be adjusted to increase/decrease preload. Need to be replaced less frequently. When working with metals that are harder than aluminum, it is important that they are strong enough to withstand the high cutting resistance during machining. By using preloaded ball screws, you can maintain a tough state without rattling. Try disassembling the ball screw housing. Preload is applied by combining the two bearings to hold the ball screw and eliminate rattling. This is the spindle of my machine. I wanted to show how to assemble after disassembling all of this spindle, but I couldn't disassemble it. This is because the bearings are shrink fitted onto the spindle shaft. In shrink fitting, parts with an inner diameter smaller than the outer diameter of the shaft are heated and expanded to increase the inner diameter, and then assembled to the shaft. After that, when the temperature down, the inner diameter becomes smaller and the shaft is tightened. This method can be assembled with high accuracy and without rattling. The disadvantage is that it is difficult to disassemble. Angular bearings are bearings that are used by applying preload in the axial direction. In the case of the type in which two angular bearings are set, by using the V mark with matching, it is possible to apply preload both the axial direction and the radial direction without rattling. The length of the inner ring and outer ring determines the preload of the rear angular bearing. The end face of the spindle case is 20 microns shorter than the end face of the rear bearing. And apply preload to eliminate rattling. This is a 3-speed gear for turning the spindle. When I designed it, I wanted to be able to change gears with G-code. But I gave up because it was too difficult. I think there are 3 main things that are required for the rotating axis for machine hard metals. Strong holding force, strong torque, strong structure that can withstand machining resistance in all directions. It need to apply preload to the worm gear and worm shaft to eliminate backlash. Worm gears, worm shafts, bearings, etc. can be purchased easily. However, the problem is that the housing and special parts to assemble them must be made by iron or steel. But I think most people that don't have own industrial machinery at home. In my case, I started making those parts with this machine when it became possible to machine 3-axis. Some people may have doubts about the structure to be shown, such as poor machining accuracy of parts and not using large parts, because there is a background that there are only poor equipment. If you are like my background and want to machine steel metals at home but don't have the machining equipment, I recommend subscribing to this channel. This channel will be useful for you. This is the shaft of the rotary axis. Install the shaft collar to the shaft, and the worm gear. The rotary axis of this machine is not designed to rotate at high speed, but I want to make it as strong as possible. Therefore, the bearing uses strong taper bearings. A preload must be applied to use taper bearings. File these heights to adjust the amount of preload. After install this housing plate, make it feel like the 4 points that have been filed are slightly floating. It become the amount of the preload. Preload is applied to the worm gear, and there is always no gap between the worm gear and the worm shaft, so if their accuracy is poor, the worm gear housing will move back and forth, like this. This will mechanically eliminate the backlash of the worm gear. After assembling these parts, the screws attached from the other side are filled with putty. This is a worm gear. The M3 cap screw is attached here. It is used to activate the home switch. It will be explained later. This is a roller bearing outer ring holder. This part is made of 9mm steel plate, because it's a material that I can easily obtain. When installing this housing, the 4 mounting surfaces should be slightly floating. File these 4 points to adjust the height. This floating amount is to be the bearing preload. The way to adjust it is to use this file. This is a worm shaft. This worm shaft bearing also preload, with adjusting this part length. This plate is an important part for preloading the worm gear and worm shaft. This spring is for preload of the worm gear and worm shaft. This part is to prevent the worm shaft from moving laterally. This part is for operating the home switch. The bar I just installed moves by being pushed by the cap screw attached to the worm gear. How was it? Did you enjoy it? I have prepared 3D CAD data for those who are interested in this 5-axis CNC machine and would like to make it themselves. I will put a link in the overview column. Please see if you are interested.